Yes, I'm Donald Trauger, and Trauger is Trauger, Trauger. My mother-in-law, when we first married, would say Auger Trauger, so she could remember it.
All right. Well, tell us how you came to Oak Ridge, or what you did as your role in the Manhattan Project, where you were from, and how you got involved.
Well, I grew up in Nebraska and attended Nebraska Wesleyan University, which had a very strong physics, mathematics, science department. And from there I went to the Manhattan Project in New York at Columbia University. And that work was on the gaseous diffusion separation process, which I was very pleased with the opportunity to work on that side of the project, because although it was for a bomb, I was which I didn't like to work on because I was really afraid of nuclear proliferation, as it wasn't known by that title at that time, but it also, the gaseous diffusion uranium enrichment process would be suitable for making fuel for nuclear power plants. And my interest was in energy, and so I could rationalize working on the project, even though it was for a weapon, so that what I was doing could contribute to nuclear power. So that's a brief thumbnail of getting from the middle of Nebraska to New York.
When you were at Columbia, were you part of the SED, or just
No, I was there as a civilian. I had an assistantship at the Illinois Institute of Technology in Chicago, but Dr. John Dunning, who was one of the leaders in the Manhattan Project for the gaseous diffusion separation, was an earlier graduate from my college, and he called the college and asked if there was someone who might fit a position in the project, and I was recommended, so I went there and found that I was to work with the barrier, which was the separating membrane, which is the key to the process, so that the uranium hexafluoride as a gas the light element will diffuse through a very fine porous barrier a little bit faster than the uranium-238, which would not fission. So that was the process, but of course it required large areas of barrier and multiple stages to increase the concentration of uranium-235, the fissionable isotope, from 0.7%, as it is in nature, to above 90%, as was needed for a weapon. So that was a major task, and it was the key element in the K-25, what became the K-25 plant, is to make a successful barrier, because although porous membranes had been used in separating isotopes that were much lighter and have much greater separation in the isotopes for scientific purposes, it had never been tried for anything as difficult as separating the uranium in uranium hexafluoride. So it was a major undertaking, and at the time I started to work, there'd been some work on it in the sciences, but and the project had only started a month earlier. It was created in July, late July, I think, and I arrived at Columbia the first day to work the first day of September, and that was 3 weeks before General Groves was named to be the director the overall Manhattan project, and it was also about 3 weeks before Oak Ridge was chosen as one of the sites to be the major site for the project. So that gets me to Chicago, into New York, and so my work was finally turned out to be to develop means for testing the barrier, to see whether or not the pores were fine enough, if they were uniform enough, and if it was a suitable structure that would withstand the rigors of the installation and the operation of the plant. So that was kind of a specialty, but and we started with a number of people running pretty much routine separations, and we were separating helium and carbon dioxide, which are easily separated, but they were a good measure to see whether or not the pores were fine enough. And but at that time we were getting little squares to test that were perhaps an inch square, and it would look like a Herculean task as it was to put the barrier in, sufficient barrier into became the K25 plant, in which the area of the barrier could be measured in acres. So from a square inch to acres is a pretty major step. So and that led to testing the barrier as it was prepared in more detail for the installation of the plant. It was decided that it would be too difficult to install flat barrier pieces, which is what we had, and should be tubular in shape. So then we had to build new equipment for that, and somehow I was selected to get that testing started, and so I eventually built a laboratory, which was a control laboratory for the production of barrier in the form of tubes. So we only tested samples of it, but we devised a quick test that could be used at the plant where the barrier was manufactured in Hoodley Hershey Company out in Illinois. And so those tests were applied to every barrier, which would give a kind of a rough test whether or not it was good enough. But my little laboratory with a half dozen engineers and a few non-technical people there for support really did the most definitive testing to determine whether or not the barrier was adequate. Excuse me.
Can you say again, because it's a wonderful thing, and I want to make sure it's clear on the tape, that you were going from trying to make this work on a square inch to acres. So describe that huge ramp up.
Yes. Well, the big problem was for the people who were developing the barrier itself, of course, to make it in quantity, because it was difficult to make even a square inch that would work, but to make it in large quantity and to make it suitable for forming into a tube, and then so it could be installed into a plant in major pieces of equipment, was really a very challenging part of the project. And there were other important features of the plant because it required pumps and heat exchangers and lots of energy to drive the pumps, or the gas circulators, perhaps more properly termed. The control system, and also the analytical system to be used with the uranium hexafluoride. So there were many challenges, and in that part of the Manhattan Project, as I think there were in every aspect of it. But the barrier was the key to the gaseous diffusion process. And as we got our little laboratory, it proved to be something of a control laboratory. The quick and dirty tests were done at the plant, at the manufacturing plant for the barrier, but we would get samples to test to determine how well they were working and kind of keep the quick test in calibration. And as the plant was being constructed and was well along in construction here at K25, and the barrier plant was in limited production, our tests began to show that particular barrier design, known as the Norris-Adler barrier, would not perform as it should in the plant. And so it became a very intense testing period because that was a major problem. And it was finally decided that it would not be suitable. And but fortunately, another method of making the barrier had been conducted in parallel, and we were beginning to get samples from that barrier, from the pilot plant, and they seemed to be all right. So finally, they had to tear out the whole plant that was built for making barrier, and put in a new process, and so that was a very intense period for the project, and it certainly was for those of us who were doing the testing. So that was pretty exciting, really, to have a part in making measurements which determined that a whole production facility should be revised and changed drastically.
There's a description of General Groves, maybe in his own autobiography, of his making that decision, coming to Oak Ridge,
Yes.
and it was costs of millions of dollars. Can you talk about that? Do you remember that he became involved in that decision?
Well, of course, the project was rather tightly compartmentalized, and security was rather tight. So we knew about General Groves, but I never saw him, and not so many people did, unless you were very high in the science group or in the management. But I've since read many books about him, and I'm disappointed that I didn't ever have a chance to meet him. But we were privileged to have many very prominent and capable scientists and engineers in the project who deserve the credit for making the project succeed, because each of those components that I mentioned earlier, particularly the barrier, were a major challenge. And so those people were really contributing to that. But the General Groves had a management capability, and he could seem to quickly decide what should be done. And as he decided, I think it was perhaps in the second or third day he was working, to put the project in Oak Ridge. So he was a very definitive person, very aggressive, but very sensible person. So he deserves the credit for managing the project and making it work. On the other hand, he had a lot of help, though, because he had the highest priority for procuring people and equipment and whatever was needed for the project, and so without that priority, he probably couldn't have accomplished what he did or what the project did in the very short time from 1942 until 1945.
Can you just talk a second about the original plans and how the original plans had all the functions here in Oak Ridge?
Well, I think starting with a barrier that was an inch square and some tests of the calutrons, which were the Y12 process for enriching uranium, which made the major part of the enrichment for the first weapon. All of that needed similar talented people to develop it. E.O. Lawrence was the principal person in that. And then, of course, the alternate weapon was with plutonium, and so it was necessary to understand plutonium, because plutonium was only known by minute fissioning of uranium from laboratory experiments in quantities too small to see, and so one of the missions of Oak Ridge, which became known as the Clinton Laboratories, and then became the Oak Ridge National Laboratory after the war, was to develop the separation process for separating plutonium from uranium. They're similar elements, and their chemistry is somewhat similar. It was a difficult separation, but there wasn't any plutonium, so there was no way to develop that except by theory, and so we had to make some plutonium. And in order to do that, you had to have a nuclear reactor, and hence the graphite reactor, as it's known, or the original nuclear reactor that was large enough to produce any power at all, was to be built in Oak Ridge to produce a little bit of plutonium so that the separation of the plutonium and uranium could be accomplished. Now, together with that in the reactor, of course, you get lots of radioactive fission products and things that make it very difficult, and this all had to be done remotely with new cells that were in which the operators couldn't see directly what they were working with. So there were many inventions had to be devised in order to make the project work. But as they began to see the size of it and began to see how large nuclear reactors would have to be to produce plutonium, and it seemed that you couldn't put those reactors in this area in Oak Ridge, and so the Hanford site was chosen, which is many times the size of the Oak Ridge site, for the production reactors for the plutonium and for the second weapon. But the Y12 plant for the electromagnetic separation of uranium isotopes was built here, and the K-25 plant, the largest building in the world at the time it was built, were also to be in Oak Ridge, but that was about as much as you could cram into 60,000 acres. When you also had to build a complete city with all of the amenities of a city in that same area, and you wanted some isolation of each of the facilities because the hazards of it were not well known. So the Oak Ridge site looked very attractive, but then it's decided that it might be too close to the coast for that possibly the Germans could somehow get this far by airplane. And so I think that it was partly the reason. I don't really know that side of the project very much directly, except from reading books. But Oak Ridge is a nice site for what was done here because of the hazard. It was nice to have hills, which would shield one area from the other if there was a nuclear accident. And it had the gaseous diffusion plant and also the Y12 electromagnetic separation plant used large amounts of electric power. And TVA was the only grid in the country at the time that could possibly expand to produce the electric power for those aspects of the Manhattan Project. So that was an important factor. This general area from northern Alabama and Georgia to Kentucky had not been tapped very heavily for wartime, peacetime side of the war production, materials and equipment production. So that was another factor. Also, the Clinch River surrounds three sides of Oak Ridge, the Oak Ridge Reservation, and cooling water was needed for particularly for the gaseous diffusion plant. So it was rather an ideal site, but so it was only when the magnitude of the reactors that were needed to make a significant number of weapons that part was moved out, and then because of the security, perhaps in part at least, Los Alamos was created in the mountainous area of New Mexico, and so it was isolated from the rest of the project.
That's great. That's very good. Can you pretend you're looking at a map, because we could show a map for the viewers in a documentary, and just describe roughly, that the Y12 was here in the southeast, and then there was a ridge called whatever the ridge is, and then the next valley was where they put this facility. If you have that map in your mind, you can just describe it to people, like with the names of the ridges or the creeks or whatever.
Well, if you're entering Oak Ridge from Clinton, and the Oak Ridge National Laboratory was then known as the Clinton Laboratories, just choosing the name of a nearby town. If you come in that way, you come into the city, and the city proper was several miles long and about a couple of miles wide. So that would be the first thing you see coming in there. And if you turn left, after you get about midway in the city, you would come to the Y12 area, which was the electromagnetic separation plant. And it was between the city property and the Clinch River on that site. Then if you continue on to the far reaches of the site, another 10 miles or so, you come to the gaseous diffusion plant on the right, and the Oak Ridge National Laboratory, or the Clinton Laboratories at the time, to the left. So, and they were separated by a couple of miles. So the site was well suited for the purpose, and it had all been farmland and pasture land. There were about 3,000 people living here, perhaps not quite that many, and they all had to leave for security reasons, and they had to do so very quickly, and sometimes only a very short time span for moving. And if you think of a farmer having a barn full of hay and a pasture full of cattle and crops in the field, and to move to a new farm in 2 weeks, or some of them only had that much time. It was a major shock to the people who lived here, and it's remarkable, I think, that they were sufficiently patriotic that when they were told that here's a project that was important to the war, that they did so without major challenge to the action that was being taken, and they were paid very poorly for their land. It was a poor farming area, so I suppose the market value was pretty low. So the government got a bargain in getting the land over what it might have cost at many other sites. But these people really made a pretty major financial sacrifice. Now, some of them were employed within the project, and they had probably made more money than they had ever made before. So there's some good aspects to it, but I always felt a little sorry for some of the people that lived here, and I've known several of them, and they were pretty shocked to know that they were going to have to move so quickly. And some of them found good places, and some of them took a long time.
That's good. What other, can you talk about, you were at Columbia, when did you come to Oak Ridge, or did you during the Manhattan period?
Yes, well, we came here after the war. I was at Columbia, and at we outgrew the facilities at Columbia, so they took over a 8-story parking garage that was a few blocks upstream from Columbia University in Manhattan, and so much of the project moved there. So, and since I was using fairly heavy equipment for providing the gas circulation and heat exchange and all that was needed for testing the barrier, we wanted a good stable floor, so I was relegated to the basement, as I had been at Philippine laboratories for similar reasons, I guess. But that, again, illustrating the advantages of the priorities, that parking garage was converted to a very fine laboratory in a very short time, in a few months time. It was changed from just a parking garage to a laboratory, and it was complete. It had all kinds of services, and since I had fairly large equipment, it was nice to have the welding laboratory nearby and a lot of talented craftspeople available, and so it was really pretty efficient laboratory facility that was created, again, in a very short time. So it was an exciting period.
Sounds like it. Did you work with Harold Urey?
I knew Urey. I worked under Urey, of course. He was around the Nash building and in Columbia. I saw him. I guess I first met him in my laboratory when I moved out of the routine testing into the laboratory where I was developing the test equipment for testing barrier tubes. He came in there one day and had seen the equipment we had, and he said, "What's going on in here?" So I started to explain it to him, and so he listened for a while until I I mentioned one of the senior people in the project that I was working directly with him, and that seemed to satisfy him. He went on down the hall. But I saw him a number of occasions at different times, in different ways.
What about Dunning?
Well, I, of course, had known of Dunning before I went there, and I didn't meet him for several days after I arrived there, but came to know Dunning and his family. And recently here at the museum, his son, who I knew at that time, and during the war, was a little boy, but he was here speaking at a seminar here, part of the 60 celebration, the Secret City celebration, and so I enjoyed meeting him again. I told him, I said, this is the second time we've met, but he didn't remember the first time, of course. But and he's a very delightful person. And
so, how do you feel about your, the opportunity you had back then during the war to work on the Manhattan Project? What was it? What does it feel?
Well, it was a tremendous opportunity for a young person because you came to know very talented people and people of prominence, and so I knew the prominent people in the gaseous diffusion process, and of course Urey and Dunning you already mentioned, but there was Sylvan Cromer, who was a leader in the project here, when it moved here to Oak Ridge for the gaseous diffusion plant. Head of the engineering, and Carl Cohen and Manson Benedict, who did the theory and designed the basic arrangement of the plant. So we got to know those people firsthand and directly, and it was sort of really a privilege and a wonderful learning experience. And Dr. Eugene Booth, who was a physicist at Columbia University, was a major part of the project. In fact, the part that I was working in, particularly with the barrier, was known as the DBS project, the Dunning, Booth, and Slack project. Dr. Slack had been head of the Department of Physics at Vanderbilt University, and Dunning, of course, became at the end of the war became the Dean of Engineering at Columbia, and Dr. Booth stayed pretty much as a major scientist, but he took a great interest in my testing facilities, particularly at the Nash Building, because it was so key to the future of the project that he would come to visit my laboratory every Saturday afternoon. We were working 7 days a week and long days as well. So I never left my laboratory until Eugene Booth came, because I'd always learned something from him that was important, not only to what I was doing then, but for me personally. So it was a great experience to be working more closely with a person of that stature than it could have been an opportunity as a graduate student, for example. Probably wouldn't have had that kind of association at all. And I later came to know Manson Benedict very well, and so knew those people firsthand. And then as a result of the project and coming to the Oak Ridge National Laboratory eventually, I got to know many of the other leaders of the project, Dr. Eugene Wigner, for example, his personal friend here in Oak Ridge. So it was a great experience and a very valuable experience for a young person like me and for many others. It was very exciting, and we were driven hard to do the job because of the espionage system that we had at the time, which was perhaps no better than what we've had lately, led us to believe that the Germans were ahead of us. And we knew at the time the security was clamped down around the world on nuclear-type work, that the Germans were quite advanced in the field, and they were doing very advanced work in missiles, more than anywhere else, probably. And so it was easy to think that we were in a race with the Germans for getting the first bomb, because if the Germans got the bomb first, they could easily apply it in England, and the whole tenor, the whole balance of the war would change drastically. So it was a great incentive to work. And one, maybe a humorous note, I don't know. At one point in the project, they employed a person who was to be kind of a personnel specialist, and he would call a meeting and tell us how important our work was and how we should be energized to work hard. But we're already working as hard as we could, and one would be so annoyed by his admonitions that it was tempting to that next evening to go to the movies instead of coming back to work. So it was quite a unique, I think, not totally unique, but a pretty unique situation with respect to incentives and to opportunities and to capabilities that were available, because whatever I needed, I could find someone within the project who could help me solve a problem, and I was able to solve a few problems for others. So it was indeed a very exciting period and a very valuable period in many ways.
Ask somebody to come.
Yeah, there are people waiting.
Oh, there are people waiting. Okay. That's the problem about these interviews. You want them to go on and on. You gotta say, well, we're out of time. We're out of time. But this has been wonderful. Is there any? And you did a beautiful job. So, not looking for more, but I don't want to.
Mm-hmm. Well, I think we've covered the part of the Manhattan Project that I was in pretty well. Although it was tightly compartmented for secrecy reasons, there was a grapevine that worked pretty well, and so I pretty well knew what was going on in Oak Ridge, because enough people came here and went back, and so that I knew about the graphite reactor and about where it was stood, and I knew about K25, of course, because I had to know about it in order to do my part of the project, and we knew of Y12. One could deduce that from E.O. Lawrence's work before the war, or before the security was clamped down. So I had a pretty good picture of Oak Ridge. I got to know a little bit about Los Alamos. I knew there was a big project out in Washington State, but I didn't have it properly identified because I thought the reactor was here. But again, I didn't understand the magnitude reactor system that was needed for the purpose at that time. It was a little beyond my background, and although I really had been studying nuclear energy because the discovery of fission occurred while I was in my second year of physics in college. So that interested me very much because as a farm boy I had watched us change from horses to tractors. And the tractor used petroleum fuel, and we thought it was more limited then than it was, but we now are beginning to know how limited it really is relative to the demands on it. So I was interested in energy, and when this announcement was made, I was very excited about that, and I actually gave a paper in a speech class about it, and the thesis of the paper was that there was so much potential for nuclear energy to replace our fossil fuels that it would surely be developed, but it also could be a weapon, and we'd have to worry about, we'd have to do something to prevent its being used as a weapon, and so the speech closed with that warning that something should be put in place, some international institution should be put in place that could control the use of nuclear energy for peacetime uses, so it wouldn't be developed as a weapon. And the organization that I described, I kind of proud, but maybe just my memory is aged, and I think my picture was better than it was, but it was something like the United Nations that I had in mind, and so I got an A in the speech, incidentally, and the professor said, well, it is a good speech and is a good paper, but in the future you should keep your subject material more current. This is too far out. So it happened that when the war was over, bombs had been dropped. She was teaching at Columbia University. And so, excuse me, I picked up the New York Times with this headline of atomic bomb and took it over, dropped it on her table after she remembered my speech. And she did. So we had an interesting afternoon. So that's just a little humorous highlight that thought you might be interested.
That's great. I guess I could ask you, I know I've got these people waiting, but one more question. How do you feel about the bomb that were dropped in Japan?
Well, we thought for years that it had ended the war, and in a sense it did. But I recently read a book titled Racing the Enemy, which is written by a Japanese person. I shouldn't. I guess I'll not try to say his name because I can't quite pronounce it now. But anyway, he makes this rather strong case that it was the Russian armies that are amassed in Manchuria that forced the Japanese to make it a quicker decision. And I've always thought that probably one reason we used the weapon was to keep the Russians from coming in particularly to Japan, because the Cold War would surely have been much more difficult if that had happened. And so I think it's still correct to say that the nuclear weapons terminated the war, but it probably would have gone much longer before the Russians were able to overrun Japan. So it's an exciting book. I enjoyed reading it.